So, all right, we have a ball. We have the mass of the ball. M is 0.15 kilograms being dropped, which means the initial velocity is 0. It's being dropped from rest from a height of 1.25 meters. It rebounds from the floor to reach a height of 0.96. So the velocity here is also 0. Remember, at the highest point, the ball goes up, 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 up. For a split second, it stops. The question is, what impulse was given to the ball by the floor? So impulse is a fancy name for change in momentum, where P is momentum. Now look, before we solve it, when the ball hits the floor, which way is the momentum changing? Is the momentum changing in the downward direction or the upward direction? In the upward. The momentum changes in the upward direction, right? If the momentum changed in the downward direction, that would mean like somebody pushed it, like it sped up into the floor somehow. Like there was, I don't know, like there was like some trap door here. It would have to speed up in the downward direction. So as a result of hitting the floor, well, just think of it this way. Which way is the force of the floor on the ball? When the ball is in contact with the ground, which way is the force of the floor on the ball? Up, right? In fact, that's the direction of the net force. The net force on the ball is up, and you want to know what? That's the reason the ball goes up. The ball hits the floor in the downward direction. As a result of the force of the floor, the ball leaves the floor and goes up. So which way is the change of momentum in this problem? The change of momentum is going to be directed upward, okay, as a result of the ball hitting the floor. Okay, so change of momentum, we're going to be using this equation, momentum final minus momentum initial. We already know the mass. What we have to figure out is V final and V initial, okay? So what do we mean by V initial? V initial is right before the ball hits the ground. This velocity right before the ball hits is V initial, and then what's V final? Right after the ball hits. So that's going to be V final, that's going to be V initial. Initial meaning before hitting the floor, final meaning after hitting the floor, right? So I think the easiest way to do this, I'm going to change my color, go to red. I think the easiest way to do this is with conservation of energy. You could also do it with kinematics, but I think conservation of energy is easier. So what type of energy does the ball start with?
Potential.
Potential of gravity. Oh, and that's with the 0 point down here. The 0 points down here. So it starts with potential, ends with kinetic. Those will be perfectly equal because the only force in between is gravity. All right, so let's solve for this velocity with that. So potential initial equals kinetic final. So this is going to be mgh equals 1/2 mv squared. The m's cancel. So the velocity we're looking for is going to be square root of 2gh. And remember, guys, square roots are always plus or minus. You guys remember that from math class? Square roots are always plus or minus. What's this velocity here going to be? Plus or minus?
Minus.
Minus, because why?
It's going down.
It's going down. See, down is minus, up is plus. So the velocity is going to be negative square root 2 times 9.8 times h, which is 1.25 meters. So this velocity comes out as 4.95, negative 4.95 meter per second. So we now have that, negative 4.95 meter per second. Now, how do we find the velocity when the ball leaves the ground? Well, what type of energy does the ball have when it leaves the ground? It has kinetic. That kinetic converts to potential. Those are equal. The only force in between is gravity. Okay. Okay, so kinetic initial equals potential final. We're going to get the same thing again. 1 half mv squared equals mgh. M's cancel, so v is square root 2gh. Square roots are always plus or minus. In this case, which one's it going to be? Plus, because why?
It's going up.
It's going up. So this is going to be plus square root 2 times 9.8, and then the h is 0.96. So this comes out as 4.34 meters per second plus. Okay, we are now ready to solve this. So we're looking for change of momentum. So any questions with that? It is. That's what this would be. This would be more of like a free response question. I would not put this on a multiple choice. It's too many steps for a multiple choice. Okay. Okay, so change of momentum. M is 0.15. V final is 4.34 minus 0.15. What's V initial?
Negative 4.9.
4.95, right? So look at what happens here. Minus a minus. What happens to these minuses? They cancel to become plus. So this gives a final answer of positive 1.4 kilogram meter per second.
Or 1.38.
Yeah, I rounded the answer.
In the first place, I got 0.09.
Oh, before you did you forget this minus right here?
Yes.
Yeah.
But I understand now.
You get it now?
Because going down is negative, going up is positive.
Yep. So look, this is hard, but I don't think too hard. This would be like, I could put this on a midterm, you know, if I told you ahead of time and changed the numbers.